Well, we made it, folks. Welcome to week two. Week two, even though we had a holiday, didn't mean to do that. Even though we had a holiday, we're still going to make some pretty good headway into this chapter on chapter two. One thing I want to throw out there right away, though, is I noticed a mistake on a comments I was making earlier last week. I mentioned we're going to be somewhere in like chapter five or four, I might have said, before we start using the TI-84. I realized right away over the weekend that was a statement made in error. In section 2.4, already in chapter two, we're going to begin using the TI-84. So sorry for that comment. That's an unfortunate statement to make. We're using it even sooner than I realized. If that's going to be a problem, if you haven't gotten a TI-84 or similar Casio model already, let me know. There are different options for getting this going, even if you don't have a physical calculator. One option is you can go to, say, the Android store or iOS store, and there's versions of this that are just freely downloadable. That's kind of sketchy because I don't know how legal that is, and Texas Instruments could give a cease and desist takedown on that app at any time. It's all up to the Apple Store for really reading those and following suit. But these can be emulated through a cell phone potentially. They cannot be used on an exam. So if you're in a rough spot, you thought it was going to be a little bit longer before you needed these, you can get one emulated on your cell phone to practice on your homework. And I'll bring some loaner calculators that you can use on an actual exam that will look similar as well. So that way you're going to be practicing it, learning how this works, and then you'd be using the real calculator on exam one. Also, I could also share this file right here if you'd like to put it on a laptop or something like that to emulate this. This is one of those legally gray zones, but if you own the TI-84, you can emulate it. So that's what I'm doing here. I actually have a physical one of these in my backpack as well. So there's some options. Reach out to me if you're in a tough spot getting this calculator going, and I can help out, give some loaners during an actual exam. That was an unfortunate comment to make. Sorry about that, but it affected some of your planning. Any questions about that calculator issue there? Okay, and at least one person's already reached out to me. I'm going to be showing the TI-84 in class, but if you have a Calxio already or you intend to buy one, just let me know what the model number is, and I can look into the functions and tell you if it has everything it needs for the class. There'll be a little bit of an extra burden on you to learn those functions on your own, since we're showing a different calculator. But I found that it's easy to just find the right YouTube video. You can just literally say Casio FX 8500, whatever the model, standard deviation, and a bunch of videos just pop right up. Well, that's my announcements for the day. We're going to return to section 2.1. We're in the example in the middle because that was the long one. We didn't want to break in half of the weekend. And then we'll get going on section 2.2, probably finishing it tomorrow's class. Any questions at all, folks, before we get started? Okay, so here's where we left off. Well, maybe just kind of a warm up. The main idea of section 2.1, carrying over from chapter one, is we have two data types: categorical data, where we're placing everyone in the category; quantitative data, where we're assigning to every individual in the sample some numerical measurement, some number. And two main ways of displaying these data are going to be through the histogram and the bar chart. Turns out sections 2.2 is when we're starting to start working on quantitative, looking at histograms. So these notes 2.1, that's all about just getting used to the bar chart. We looked at one, that was this one on the very bottom. This was days where a pregnancy actually happened on days of the week, and we noticed something is really off about this bar chart. This was an actual outlier. It happened to be a numerical typo where 3 was just duplicated. Now our job is to look at this from scratch. How would we build our own bar chart? What does the data even look like? And what is some other interesting context behind this? So we'll look at this definition as we get going on the part B right here. Let's first launch into the example, and then we'll read through the definition just to make this flow a little better. So example 3 says an automobile marketing firm. I believe these data are made up, just full disclosure, but still very interesting and realistic looking data. An automobile marketing firm conducts a study to see what types of cars people owned before buying an American car. So that's a really specific statement. Maybe this is someone who sells a lot of GMC cars, maybe someone who sells a lot of Jeep, Dodge, or something like that. Maybe it's Ron Sayer, well, he's Toyota, or someone local who sells American cars. If this person wants to improve sales on the car lot, it's brutal in the car industry right now. This is really good data. What are you driving right now? How can I target my marketing at you so you buy my GMC off the lot? So if you are the car salesman owner trying to direct your sales team, this is really important information. So a marketing firm helped out with this. Someone conducted a study and put together this data. And this is easy to kind of miss when you read through this problem the first time. This is not the car they bought. This is the car they drove onto the lot. Maybe it's going to be a trade-in potentially, but it's their prior car, and we're trying to sell a GMC, some American car. It says, see the Excel file titled example one data set. I don't do this very often, but sometimes the data sets are just huge. I can't put it on a Word document. Whenever it says to do that, the document is really just going to be indented right here under the lecture notes. So there's the Excel file, and you don't have to have Excel for this class. This is only just for demonstration purposes. And here's the demonstration. Here's our data set. Let's go back to the problem. We'll see those definitions in a moment more carefully. Kind of hard to move that thing on. Supposed to click on something. There we go. So subject one is just, it could have said Mike Jacobson, and I drove onto the lot with maybe some GMC car, maybe it's a Cadillac, that's another American make. And that's all they want to know about me. They didn't say what I eventually buy, if I bought anything at all. So this is really targeted as a data set. So going through this set of data, here's what it looks like. Now imagine with me, the marketing firm shows this to you and you own this lot and you're trying to make informed decisions on how to direct your marketing, how to direct your sales force. If this is all the marketing team showed you, they walk into your office one day, remember, you paid them good money. This probably was a costly study. There's a lot of people in this. We're already to row 500s and 600s. And this is all they showed you. Here's your data. Would you agree you'd probably be kind of upset at that point? Because this is just raw data now. It's hard to know what in the world is going on unless you have a really good eye. Some people might notice as I scroll through these, there's a lot of American cars, right? So it seems like a lot of the prior owners at this car lot came in with an American car. That's helpful. We can target the sales staff by saying all the good things about American cars. So we're gonna have to work hard on all the marketing specifically for that. But here's the challenge on this. This is why we want some really good graphics. Even though this data might look nice, you might be able to tell a good story through it. It's fundamentally kind of useless. So part A is saying the marketing firm were to make any decisions with that data set right there, what would you say the major difficulties are? In your own words, what would you say would make you upset as the owner of the lot? In other words, what's just challenging about this data? Absolutely. We're just scrolling through a whole bunch of lines. We don't really know much about anything about this. So let's say here, this is hard to read and process. Once I spell process correctly, we'll move on. And process because there is too much data. We have an overwhelming amount of information here. I mean, this is good in a way, right? It's a large sample study. It was highly costly. Let's get to the bottom of this. The sample size on this study would have been 1268. So there's 1,268 people in this study. Let's write this down as just a comment. N is 1268 for the sample size. So this data is way too hard to read. This is just a whole bunch of information. Most humans can't scroll through 1,268 rows and have any idea what's going on. I don't even know what all the categories are just looking at this. Sure, there's a hint over here. It's been listed out. Other, it happened to be a category, and I never even knew that scrolling through here. I don't think I noticed that Korean was in here. I'm actually on a row with Korean, but that was invisible to me. Maybe that was a Kia or something like that. So that's our challenge with having loads of data. Same kind of challenge would have happened over here, but everything was kind of tabularized in a nice way. This table happens to have a name. This is called a frequency. Table, or you might call it a frequency display. So that takes us into the definitions we're going to take a look at. And that's what this was, what we built in Excel. Sometimes when you're looking at a frequency table and trying to determine what the variable even is, the table's now confusing because the data looks like this. Much like in our problem up here, the only variable is previously owned car. That's it, just one categorical variable. These are the categories. So we have a table down below to help us understand this. The definitions say a frequency distribution of a categorical data is going to tell us what are the actual categories for our one categorical variable we're considering. Here's the categories: American, Japanese, Korean, German, and other. The frequency is just going to tell us how many times did every one of the categories actually show up. I remarked there's a lot of American make models here, and the frequency table tells us definitively 760 American cars in this data set of 1,268. That's pretty helpful information. So if the marketing team did just this, and we paid really good money for the study, we're upset. They didn't do their due diligence. Sure, this was hard to get, but they need to now give us some information, tell a story about this data. If the marketing firm gave us this, a frequency table, will give us all the categories and the number of times the category turned up. That's a little bit better. I think most people would agree. Now we don't have graphics, but this is a start, right? You can tell if you own this lot that if you're really interested, maybe you're selling American cars primarily, most of people here, let's take a look at this again, see what types of cars people own before buying an American car. If you are about to buy an American car, your previously owned car was an American car. Let me read this context one more time. I think I might have myself personally got a little mixed up. I think I might have said earlier on when we were first looking at this, we don't know what car they bought. Yes, we did. On yellow here, this is why reading the context several times is really important. This is the car they previously owned before buying an American car. So 1,268 people that eventually did buy an American car. And this is what they drove onto the lot to make that purchase, essentially is what this is saying. So sorry if I got you jumbled up on the context there. I was jumbled up myself. It's good to read these things multiple times to make sure everything makes sense here, because even with this short description, it's kind of tricky sometimes. Does that make sense to folks with that clarification? Okay, so everyone bought an American car. And this is telling an interesting story already. This tells us if you buy an American car, really strong overwhelming chance you already had one. You just like them, is what this is kind of saying. That's pretty interesting information. So maybe the marketing firm doesn't care as much about people who already have an American car. Maybe they want to talk to people who own the reliable Toyotas. Maybe not the electric vehicles as much anymore, but maybe the marketing should attack the Toyota. It has a reputation of being reliable. We can say something about American cars being more reliable in 2025. That's probably a better marketing campaign, because these are the people who are already convinced. They came with an American car, they bought an American car. So this is the value of having something that tells us what the data looks like, some way, shape, or form. And this is just the frequency table, or just frequency distribution for the one categorical variable. We can do even better. Some people don't like the raw numbers like this. You might have already personally been thinking, how does 760 relate to 1268? What is the percentage of that, for example? So if you're looking at this and thinking, is that half? It's hard to tell the numbers here. Even with the sample size given, it's not easy to get the percentages. And you're not alone. A lot of people don't just want a frequency table. They want to talk in percentages or proportions. So that's what the relative frequency is all about. Sometimes our graphics are like on the frequency. Other times we do this computation. So relative frequency is going to be the frequency, number in blue, divided by the number of observations in the data set. And we just check that out. We scrolled to the very bottom and found there's 1,268 observations. So that was the sample size here. Let's point here for just a quick note. This is the sample size. Just another way to say number of observations. So this is a pretty quick computation for us. Word of warning, if you've worked ahead in MyLab statistics, the homework system, it is finicky. So sometimes putting in these answers, they're hyper-specific. For example, if it says to round to 4 decimal places, sometimes it really literally wants 4 decimal places. It's being verbatim here in the instructions. So let's work this out ourselves and just practice that. If you're putting in numbers and you feel, you just know in your heart they're right, and it's not accepting them, this is usually where it's going wrong. But if that's happening to you, click the Ask My Instructor button and I'll take a look into it in the system. And if I see your numbers are right, it's just a rounding error, I'd probably alert you in the email reply and just give you the points, since I think that's something small to fuss over. So again, the numerical portion of MyLab statistics can get gnarly, and never hesitate to just reach out the moment things seem like they're getting a little funky or just not accepting answers that you feel they should be accepting. That was my quick spiel on that. And by the way, I was talking to technical support on MyLab statistics. When you click on the Ask My Instructor button, it sends me an email to my ISU email right away. And I thought I could reply to that and you would see it inside the homework system. Turns out it works differently. I get the email and I'm going to have to email your ISU email to give you the reply. So if you use the Ask My Instructor button, have your email open as well, since that's where I'm going to be replying to you directly. But we're ready to start. As promised, every single time you have to use a calculator, I'll fire up mine here. And because this is a required part of the exam as well, it's always good to have your calculator ready to go. Practice along with me. Even if it looks simple, you're just getting used to the layout of your calculator. You don't want to look at it for the very first time the moment you crack open the exam. That would be kind of a rough experience. But this is kind of just a routine computation, so nothing too major. Let me see if I can fit it over here. The keystrokes with this would be just type in 760. We're dividing by the number of observations in the data set, so just division 1268. It's right over here on the right panel, and I'll just print out a slash going that way. Divide by 1268. And there's our first one. We're rounding it to 4 decimal places. So let's also practice that as we go, because again, that's part of the burden in the homework system, getting that part down pat. If it says round to 4 decimal places, that means go to the 4th place, right here. Then observe the number 1 place to the right, so now the 5th place. So just underline or just fixate your eyes on the 4th decimal place. Because the position is greater than 5, or if it was equal to 5, that means we round up here. We record 0.5994. 0.5994. And again, this is kind of heartbreaking in a way. If you put in 0.5993, this comment can save a lot of keyboards. This is probably why it's being marked as incorrect. You do have infinitely many tries, but this means it can be infinitely frustrating now. So don't hesitate to just hit Ask My Instructor button as another call out for that. So put in 0.5994, and now we're being super careful with the rounding. Does that make sense to folks so far? Okay, there's not a whole lot of mathematics in this class. Sometimes we use formulas. This is the first real, just pure mathematical concept we have to be careful about. mainly just because of the homework system. Well, it's rinse and repeat. 4 more categories to go, but notice that's interesting already. 60% of the sample of people who bought American cars had an American car already. So marketing there may not be so useful. We might be more interested in converting the remaining 40% into buying an American car. Sometimes people who have Japanese cars, they are very, very loyal. 375 happened to buy an American car, so we want to know all about them, why they did it, so we can duplicate that kind of success. That's the whole idea of this study here. One thing that's nice about this calculator is you could just keep on typing. You don't have to clear anything out. Sometimes you want the prior number, and so we'll use some shortcuts in the calculator to access it. But from here, just type in 375, divide by 1268. By the way, if I ever get my numbers backwards, never rude to just call it in class, hey, Mike, you typed in 1286. And that'll be helpful for everyone, me included. So I'm not going to be super specific on the rounding, but just for extra practice, here's the 4th decimal place on this one. This time it's a 4. If that was a 5 right there, we'd have rounded up to 0.2958. But if it's 0 through 4 on that digit by the red arrow, we just keep the 7 exactly as is. We're rounding down to 0.2957. So 0.2957. Then on our way to the next, some people are possibly already done. Let me work through the last two. 72 divided by 1268. This one is going to be a 0.0568, rounding up on this one, 0.0568. One of the common mistakes I personally make is miscopying a digit in. Just about did it. 0.0568. That's frustrating. So one of the things as just a helpful comment on MyLab statistics, the slower you go on this, possibly the more time you're going to save. It seems weird, but go slow in the numerical stuff. You'll catch all the silly mistakes, and you'll probably spend less time on the actual question. And if you're just getting tired of dividing by 1268, here's a new calculator trick that we might as well discuss right now. It becomes really helpful later on. You can access the prior entry right here in a number of ways. One way is up arrow. You'll highlight that. You can hit enter. Now you can use the left arrow to just move over and put in, my next one is 37, divide by 1268. And sometimes that's a great trick. Anything you could do to speed up the calculator is going to make you more accurate, since the more times I type in 1268, the higher the odds I'm just going to mistype it eventually. So that's a trick we're going to show often just as a speed up here and there. 0.0292 rounding up. Double checking is always a good thought here. And let's use that shortcut once again just to demonstrate. No harm in just typing in 24 division 1268. But if you up arrow until you highlight that, hit enter, and then left arrow, we'll use this pad here a lot to edit things like this. And then just overwrite, type in directly 24, enter, and that's our next computation. This one rounding down, 0.0189. So we finally did it, folks. This is the whole data set. Now is a relative frequency display. These are helpful numbers because, again, it's telling us if we're going to make an ad campaign for marketing to try to get people to buy more American cars, maybe we won't spend a lot on looking up German cars because that's about 3%. There's other makes here, so that might not be worth our time if we have limited budget on marketing. Maybe the best bang for the buck is Japanese and Korean. That'd be about 35% of the data already. So if we can say something negative about Japanese or Korean cars, we're going to have to work pretty hard. Some of these are excellent cars. To make American cars look better, then that's what this whole study is all about. Just getting people to buy more American cars. Not because we're super fans of it necessarily. That's just what this problem was about specifically. So if you have a favorite Toyota, not dogging on your Toyota or anything like that. But any questions at all, folks, getting through this problem? Okay, so once again, when you look at this table, this is good. Lots and lots of work was done to produce this data. The marketing firm has to show it to whoever owns this car lot to say, well, here's the fruits of our labor. This is why you spent for that size study, maybe $20,000 or more on something like this, depending on how much data they really collected. Oftentimes, these studies have actually loads of data, maybe 12 categorical variables made sense, maybe some quantitative variables. We want to learn as much about these people as possible. We're just doing a simple slice of it to look at this one variable at a time. But after doing this much, it's still not good enough. We want graphics. And just about any kind of marketing meeting you can imagine, think of something in a like almost a movie trope. You're going to see graphics, things like pie charts, bar charts, and so on. We're going to focus fundamentally mostly just on the bar charts. Pie charts are going to come up just a little bit on the homework, but nothing too major. The ones you might be asked to do on a quiz or an exam setting is something like this one, constructing our own bar chart. So we'll do that here and make some just really brief comments after we do our construction. If this does come in as an exam question, the rest of exam one is a little bit shorter because this takes some time as we're going to see ourselves. But let's give it a try just in case that does become a question. So the idea with the bar chart is we want a horizontal axis, probably a pretty long one in this problem. We're going to be using relative frequency, and relative frequency is going to be on the vertical axis going this way. Because relative frequency is coming up, we're really just using percentages. If we leave it at the relative frequency form, this is a number that goes from 0 up to 1 at its maximum height. The biggest number we have on here is rounded up to about 0.6. So I'll make it 0.6 be the maximum height right here. You can make a lot of choices. You don't have to do it specifically the way I'm doing. You might have gone all the way up to 1.0, for example, and that would have been just fine. So let me see if I can make these tick marks work. Here's 0.1, here's 0, 0.2, 0.3, 0.4, 0.5, and I was worried about that. My spacing is not perfect, but let's leave it there. If you had it something like this, that's totally fine. I'm not going to be specific on having a perfect hand or being an artist on this. I'll fix it just for the sake of the notes. It goes up to here, 0.6. So that's our height. We have one categorical variable, previously owned car is the title of it. But on this horizontal axis now, all we're putting in is the categories. If it came in this order on the table, it'd be weird to mix them up. You can do that if you're just feeling like you want to be extra creative. There's no harm done. But the ordinary thing you would do is keep the same order you see it on the table. So I'll call this one, you might have to write kind of diagonally to fit this all in. This will be American. And on the American category, we're just going to make a bar. Makes sense, this is going to be a bar chart. That represents this number, 0.5994. That means it has to go essentially to here. I can't get it to exactly 0.5994, so I'm just trying to get it right on the line, 0.6, slightly lower, but again, as long as you're in the right neighborhood, your art is going to be just fine. I personally shade these just to make it seem like it has some depth to it, some dimensionality. Then it's just rinse and repeat. Next is Japanese. Height on this one is at just below 30%, so up to here. Next is Korean. This gets a little bit harder. This is at 6%. I notice my scale is, well, gonna get really compressed now. halfway is about this height. I'm just slightly above halfway. So do the best you can. This is maybe not perfect. I'm trying to make them all equal width as well, so it doesn't look like we're trying to make areas look smaller. It might feel like a diminishing impact if we did that. So do your best to make them look like an equal area and try to get it. I'm going to use a temporary dashed line to see it roughly at 0.6. Sometimes a note card is a great trick here. Let's see how close this got. Here's my note card. So that's at 1, that's at about 0.5. I'd say that's pretty close. I might be a little too tall, but again, it doesn't have to be perfect. I'll always understand this was a by hand sketch. So let's let this one slide, even though it's definitely not perfect, maybe slightly too tall. Now it gets really challenging. German. So this is at 3%, half the height of this one. So as long as I go off half the height to the one to the left, I'll be showing about the right size. There it is. There's about half the height. And now I want to do, well, this is about 0.3. This is about 0.2. So I need 2/3 the height on the other category. This problem was selected specifically because it is hard to do this by hand. So just make it kind of look slightly smaller. You could lose credit if you did something like that, right? That's obviously not quite right. If you gave me something like this, not quite right either, but I would let that slide too. It's just a by hand sketch. We're not robots or machines, so just do the best you can. I would try doing the best I can to do something like this. Practically looks like it has a 0 height to just really make it look small. Some people might even do something kind of like this, just sort of put a line here that looks bold. That's a good solution as well, and it's not terribly misleading either for a by hand sketch. Let's maybe let this one slide. That looks about right. We did it, folks. This one is kind of a challenging thing to draw. Let me redo the horizontal axis. You don't have to, but if you want to make it look slightly nicer, that's probably was a mistake. Let's leave that in. I want the height exactly where it was. Usually you would terminate the axis here, but let's let that stay as is, so I don't have the heights looking a little bit messed up. Well, that's the hard part. Computer graphics are typically going to do this always for us in statistics. If you know you're taking more statistics, maybe you're taking biology, nursing, and you have to take another add-on statistics class, we'll start using computer software to build out these kind of graphs. Whole reason we did it by hand is just to see how does the raw data from here get into a relative frequency table, and then make its way down into the actual display itself. Just building it by hand is a great way to see everything going on. Any last questions, folks, on just building the graphic? Okay, here's the hard part now. Comment on the bar chart using the context of the study. Again, this whole thing could be a real exam question. And if I needed something specific on your comment, I'll bake it into the exam question. For example, if I feel like there's 2 key points, I might say, mention at least 2 items in your comment. If I say something like, briefly explain your choices, then just saying bar chart because it's categorical, histogram, quantitative, that qualifies. So I use briefly as a big giveaway. You're not meant to say much. But here, if it says comment on it, I'm expecting pretty much a 1 sentence. You might have several sentences. You can share as much as you like. But anything that seems like the biggest thing that jumps out at you is probably what you'd want to say. Any volunteers for the comment on this? Sorry, say again.
Types of cars. This bar chart represents people who own what cars they own before purchasing an American car.
Gotcha. So this represents what people owned before buying an American car. This fits the instructions to the letter. I didn't say what kind of comment to give. Notice I didn't say, if you own this car lot, how is this data helpful? Some people, that might have been your comment, and I'd say that's equally great. So if it just says to comment and you make a comment that is completely true with what we see here, it's an acceptable comment. So thanks for contributing that one. Any other questions or additional comments people would want to give to this one? Okay, again, these are uncomfortable questions in a way, this thing highlighted in yellow. They can come up on quizzes and exams because it's wide open. You can say anything, anything that pops out to you, anything that's factual. If I don't give more information on what comment I want, this is a wide open question. There can be as many different responses as there are people in the class right now. Other people might have added an additional comment. It looks like just about everybody, 60%, is owning an American car. Other people might have sent the categories Korean, German, and other are highly negligible. It seems more important, American, Japanese, Korean. All of those are great comments. So if that was your comment, stick with that. Other questions or comments on this one? Yeah. Yeah, I'd say that's a great thing to add on this one. If this was a real exam question and we literally drew it by hand, yeah, that's a wonderful comment. I think that's a creative one as well. Let's add this in here as well. Let's say here, this chart may have errors due to it being hand drawn. Absolutely. I think that's a very creative comment to add on this one. I wasn't thinking in that direction as well, but it's completely honest, right? If you took this as 100% fact, we could be in danger. You really need the precise information as well, unless computer graphics did a good job drawing it. And even if computer graphics did draw it, there could be issues where maybe the picture was fuzzy. Maybe someone took a screenshot as a JPEG and it got compressed and it just looks weird. That is a great comment to add. So if you ever had an exam and I print out something that just looks a little bit off, excellent thing to say right away. This could be a misleading graph just because it just looks odd now. I'll try to make sure that the things print out appropriately. We have a pretty expensive color printer on campus, so that's usually not an error or an issue. Any other questions or comments on this one? Okay, let's add maybe just one additional one just to finalize it. Again, usually I'm expecting one sentence or a couple sentences. You don't have to give me a whole lot of information, but this could, for the last thing, just could be something along the lines of, it seems marketing should not focus on the German other categories. And I brought in a lot of my own personal context when I wrote that out. What I'm thinking is this car lot has limited funds for marketing. They just paid for a really big, expensive study. So they want the most return on their money. They should market directly to Japanese Korean. If I had more space, I might have written that in. And this is a lot of a response. So just a reminder, one sentence kind of does the job. You can wrap this up pretty quickly. And you're encouraged to do so on exams. On exams, always watch the clock. It's easy. This happens on a lot of exams. That's why I harp on it a lot. It's easy to just get lost on one problem and write down like paragraphs of information when you really should just move on to the next question. If you have more to say, just come back to those kind of problems at the very end and add additional is a great strategy. Well, this is the full conclusion of the notes, folks. We got through section 2.1. The homework section on the My Lab Statistics is pretty basic, but again, watch out for this style of question. It's deceptively tricky because of the rounding. Well, let's save this off and we'll go off to the next section next. Looks like we have about 30 minutes. We go to 8:40. I'm still getting used to my own schedule, thanks to the long weekend. And shouldn't have closed section 2.1 too fast, but like we mentioned before at the start of class, this is what section 2.1, section 2.2 is all about. Section 2.1, we focused on categorical. Now in section 2.2, we're going to look into quantitative. I indicated histogram as our main display, but honestly, there's a lot of different displays we're going to take a look at. Histogram just happens to be the one that we're going to focus on the most once we get through the end of the notes and in the next sections. But here's a gentle start. We also mentioned histograms are really hard to plot, a lot harder than bar plots. You have to do a lot of different kinds of math. So we're not going to cover sketching a histogram by hand. When that comes up in the reading in the textbook, you're free to skim over that or even skip it outright. When the histograms come up in this course, it's going to look like this. I'll have them pre-plotted. Our job is to visualize them. And that's routine for a real statistics class. These are almost never drawn by hand any longer. Computer software has just taken over this task. But still, sometimes it is nice to get a hand-drawn sketch. That's what we're going to do here on example 1, part A. We'll do a dot plot to show how, if you have to do something by hand, here's one technique to get quick by hand graphics. This one's real data from 2014 off the FBI website. I don't do the FBI website too often. Some of these data are really kind of gnarly, heavy, serious real world stuff. But occasionally it's a good idea to handle that kind of data because statistics does have to consider rough data like this occasionally. So sometimes we'll do these kinds of data sets. Not often, but some people might be interested in criminology, so this is a great example on its own as well. It says the following data on violent crimes on a Florida college campuses is during the 2014 is from the FBI website. I said that in a weird way, so here's the full statement. So it says on Florida college campuses. This is not all of them. Florida is a gigantic state, so looks like we just have a selection of them. Let me count these off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let me know if I miscounted. Looks like this time the sample size is n equals 15. I have no clue how the FBI got this, but FBI has really good methodology in statistics. This is likely both random and representative for the entire state of Florida, or else the FBI probably wouldn't have even published this. That's something you might want to look into if you want. You can literally go to the FBI website and find these kinds of data sets. So sample size at 15. And just some reminders on what we studied on the prior sections. This is not a variable. These are the individuals. Of the data set, or the subjects of the data set, or you could say the objects of the data set, or just the members of the sample. Lots of different ways to say that. Sometimes they're actual people, other times they're campuses, other times something more abstract maybe. This is the quantitative variable. So like in the last section, we're just looking at one quantitative variable this time. Chapter 3, we're going to look at two categorical variables together. And then other chapters like 4 and 5 are going to look at two quantitative variables together. So we're going to do some variable mixing as we go through our chapters. But for the moment, chapter 2, just one at a time. So here's the quantitative variable. If you just select a random campus, here's me doing a random one. Florida International University has 9 violent crimes. If you're looking for the extremes, University of Central Florida has 29 violent crimes. Pensacola, let me know if I'm mispronouncing this. Pensacola has 0 violent crimes. Someone might have noticed something interesting about these data. I said, seems like the scariest campus in a certain sense is this one. But you know, that's not fair because something is missing here. Anyone can see a way in which this is not completely giving us the full picture. why 29 violent crimes might not be as bad as we think, even though it looks bad on paper. Kind of a weird. Sorry, go ahead. Exactly. This is not a per capita number. I don't know how big University of Central Florida is, but it could be gigantic. For reference, ISU is like 20,000 students. This could be like 100,000 students. And all the other ones could be, oops, all the other ones could be really small community colleges. So maybe that number is actually the best number on there once we look at this as a per capita percent of the student body that experienced a violent crime type of basis. So always wonder about those weird things about the context, or else we're giving this university a bad rap. And maybe I'm wrong. Maybe this is a small community college, and this is just way worse than it even looks on paper. We have to do all the extra research to really know what's going on with this quantitative variable. So we're just doing a surface look at this. We're wondering, how do all these violent crimes stack up by constructing a plot of just this information? But that's important context because, once again, don't think these are necessarily good or bad universities until we do even more research on this. There should be a new quantitative variable that says percent of student body experiencing a violent crime. Something like that gives us a much better view. But let's begin. If we want to dot plot, here's how we would start. First thing we want to do is determine the maximum and the minimum in this data set. So scrolling through the numbers, let me know if I missed them, but I believe the maximum is 29. Some people could just glance at this and see it all at once. I'm more of a read it line by line kind of person. And the minimum is 0. If the red dot is my finger, that's probably what I would do. Just go down each one of the lines, looking at them in turn. Now, next thing we'll do for the dot plot is we want an axis that contains both a max and a min. So it's just going to be a horizontal axis going like this. Give it a little bit of space. We're going to put some dots, as the name suggests, with a dot plot above this axis. And next thing we want to add to this is, on this horizontal axis, let's give the actual name of the quantitative variable so that when people read this, they don't even need the chart above. They can just read off what is going on by this display. So the quantitative variable name is number of violent crimes. I'll abbreviate it to just number of violent crimes and leave the reported specifically in 2014 as part of the larger context. So you don't have to write down everything verbatim always. I think this is enough information to really see what's going on. Notice though that that word is also really important. It's being honest that these numbers are just what was actually made into a police report, that the real story could be very different again on all these campuses if they did some other kind of, maybe go to Edison State College, do a large sample of everyone in the entire student body and just ask them, were you a part of a violent crime? They might have slightly different numbers than what was expected that was actually reported in a police report. So all the words here turn out to be really, really important. But we have our axis down. Next, I'll put a little tick mark here. I had an arrow, but we're starting at 0 for our minimum and moving to the right. The max is 29, so we have to make some judgment calls. What you don't want to do is go 1, 2, 3, 4, 5, 6, 7, 8, 9 up to 29 because you're working super hard. You probably don't want to go 0, 10, 20, 30 either, because then there's not a play between each one of your tick marks. Oftentimes you have to make a really big judgment call. I think this one going by 5s is probably the best compromise. So I'm going to go 0, 5, 10, 15, 20, 25, 30. And now my axis is kind of exaggerated going off here on the right. If you left it just like this on a quiz or exam, perfectly fine. For the sake of the notes, let me stretch this out a little bit better. Let me try harder. Let me extend it about this far. 5, 10, 15, 20, 25, 30. I'm personally not great at these. That's why sometimes it takes me 2 attempts to make it look pretty. It doesn't have to be pretty. If it's accurate on paper on your submission, that's good enough for me. Now, here's the tedious part. You might be asked to do this on a quiz or an exam situation, so we're doing it ourselves. And you might be asked to create some of these graphics as well on my lab statistics, the homework system, which sounds weird, right? How can the homework system accept a work like this? Well, it's multiple choice. The best way to do those kind of problems is just get out some scratch paper, work it out by hand. You're practicing what could turn up on a quiz or an exam. Then once you've done this by hand on paper, then look at the multiple choices and just select the option that matches up yours. That way you're using the homework system at its best. It's really helping you, and you're not kind of like speed running through the whole homework. Well, here it goes. Here's the tedious part. First one is 3. I'm going to slash these off as I go, just as kind of a note-keeping or tally device. Place 3 on the number line where it seems to best fit. I'm not going to try to put it in precisely. This would be about 4, so 3 would be about here. And there's the first dot. If you put it directly on the number line, that's a little bit weird to be completely honest. Wouldn't make you lose points, but more typically it floats just right above where the number line is. So that's how you're usually going to read it in the reading and when you see it as a homework problem. Next is right at 10. This one's easier to place. I'm just going to put it right here, right where the tick mark is above the number line. Next one at 5. Right here, right on the number line. And already there's a little bit of a drama on this one, right? If 5 shows up again, imagine these are like marbles in some kind of system that's closed in. The marble just comes down and stacks right directly above. The whole purpose to dealing with this is we want to see where do the observations kind of congregate? Where is all the data clustering? How spread out it is? And this is already giving us a good view just based off the first 4 campuses. Seems to be centralized between 3 and 10, right around 5. But the story changes each time we put down a new tick mark. So here's one at 9, just slightly to the left of the 10. One at 15, now clear to the right. One at 2. This is getting kind of tricky. I'm going to just claim that this is 2. I'm noticing my first scale was really wide and then it got narrower as I went. If this is you, you're doing it by hand. That's okay. Just do the best you can. When I go to grade these, I'm just looking, does it look right? Are all the points in the right ballpark? And you get full credit. Doesn't have to be perfect. Next one at 0, so right in that location. Next one at 1, so right here. At 4, right here. 29. Already this might look pretty amazing, right? You might have spotted 29 just seems unusual just based on the data here. But to me, it definitely feels extremely impactful when you put it on a scale like this. It's clear away from the main grouping of the data out here. Anyone recall what we might call this one? Absolutely. Anything that looks different is an outlier. We saw an outlier already in section 2.1 when we noticed one of the bars is extremely bigger than all the others. We may not have called this one an outlier. It's a descending pattern amongst the categories. Nothing unusual here. There's just more American. But one category sticks out amongst 7 in total. That's weird. An outlier is like being the person wearing a purple shirt when 100 other people all around you are wearing gray shirts. You're the outlier now. You stand out. That stood way out. This stands way out. Giving a definition and a perfectly nice definition for what an outlier is actually pretty hard because it all depends on context. Outliers for quantitative data means your observation is away from the main grouping of data. For categorical data, an outlier is something that just does not fit our expectations, some category that is well different than all the rest. But let's mention this already. That's really important on this data set. This is not just an outlier. I would probably consider this to be an extreme outlier. You don't have to say it's extreme, but if it looks like it's just way, way out there, no harm in saying overwhelmingly different, an extreme outlier, anything like that. So in other words, if my dot was here, I don't see an outlier anymore. It's kind of, sure, it trailed off, but it's with the data still. That's not an outlier at the moment. If it was here, I would start to say, hang on, the main grouping of data is here, trails off around here, and the one left the pack over here. It's an outlier at this point. Notice it's all qualitative. It's up to you to visually determine what feels weird. This isn't a formula. We'll have some later on if you're curious about formulas for this. It's all subjective entirely. And for me, subjectively, when it's way over here, it's becoming extreme at this point. Well, let me just Control Z that back to where it was. Any questions or comments so far? Okay, again, saying something purely subjectively is a little bit weird. You didn't have to say it was extreme, but if it feels extreme, you might as well say it. It doesn't hurt. And we will get formulas down the line that's going to tell us definitively, by a rule of thumb, what counts as an outlier or not for only quantitative data. But let's go through the categories. 15 occurs again. That one is stacked. 4 occurs again, stacked over here. 15 occurs again, stacked up to that position. 6 occurs again, off to the right here. So we did it, folks. This is a really interesting data set. Usually when I do something like this, the slashes are just for my own benefit so I don't lose track. I'll usually take that off so it's not so distracting. But now we can get a good feel for what's going on for these hopefully 15 representative universities and campuses in Florida. Again, it's misleading. This is not per capita basis on the student body, but this is the amount of violent crimes you should expect. Usually it's around 5, right? Trails off to around 0-ish, trails off to a concerning 15. It starts to group up again. And one of them didn't really fit the whole story. There's an extreme one as well. Next thing we want to do is the tricky part, comment on this one. This one's a different kind of question. Sure, we're going to comment on it just like before. When we did this in section 2.1, we wrote down one comment. And for these instructions, one comment did the job. This one asks for a little bit more. So when we give a comment, we really have to hit this part this time, or we could lose credit. This is the only way you might have lost credit on giving a comment on a display, if the question directly asks for something in your response. So we might say something along the lines of, comment using the context of these data. You know, that's really important too. Let's highlight this as a very important word and explain it as we go. When it says using the context, that means you have to say this somewhere, even just once. It's good enough for me. You can't say most observations are around 5, one extreme at 30 as an outlier. You have to say something about what's going on with these data. This is pretty good with context if you're saying number of violent crimes. But the larger context is also that this is Florida college campuses during 2014 coming from the FBI website. You don't have to say every bit of that, or it feels like you're duplicating the whole problem. You can shorten it up. So to me, these are the two main parts of the context. The fact that it's in Florida, that state. Let's bring in the year. That's interesting as well. It's 2025 already. It's kind of old data, so that's important to us. And the fact that we're talking about violent crimes. So something that hits context and also gets on the additional statement here would be most violent crimes in Florida campuses in 2014 are around. Some people might say different numbers here, but look for where it's congregating. Loads of campuses around, you might say 4 or 5 violent crimes. So let's say around 4 crimes. If you end the statement right there, I'd say that's fantastic. But to other people, that looks important too. You might say, and another grouping around 15 crimes as well. I'd say that's a great additional statement to put in. Let's leave it off just as this, so we're making kind of a more precise statement, but just want to say there's lots of great ways to answer this question. It then asks, which school stands out from the rest? We're talking about the outlier. It's this one. So let's mention here, they want to know which school specifically, so we need to say University of Central Florida is an outlier, or you could just restate stands out from the rest. But saying it's an outlier or an extreme outlier, actually let's go with extreme just to match up the notes. It's just a great way to paraphrase it's standing way out. University of Central Florida is an extreme outlier. So when we said crimes, Florida, campuses you may have excluded, and that's okay. I would have read that in the overall context where we know we're talking about campuses. I think it's a good one to put in. But I want to highlight some of the ones I think are the major features. These parts are all the context. And on a real exam question, these are really kind of easy to miss. So whenever I ask for context on a quiz setting, I'll always make sure if you miss this question to say exactly what I mean. Probably I'll box it out and say, we need to add this for the context. So always look at your feedback. If you lose a point on a quiz, not a big deal. That's not going to affect your score so much. But you'll need to be ready for getting that context in when you do a similar question in an exam setting. Does that make sense to folks on describing this display and the discussion on the context? Okay, well, this was my take. You all might have had different things you want to add. Any volunteers for adding anything additional? If there's anything additional you'd want to put down? Okay, let's leave it at this. Maybe one additional comments because these are all things that are coming up soon. When we said around 4 crimes, we were talking about this grouping of data right here. So what we were saying here, as just an additional comment, the central value, let me put a little border here to say this is just an extra remark, not meant to be part of our answer. So this is just a remark. The central value is of great interest and is called the mean. That's a weird word. I'm actually not a fan of this word. It's an important word because in the language of statistics, we use the word mean all the time. If this feels like a weird word to use, you might be saying, what did he mean about mean? This is a non-grammatical statement. What we mean is average. I'll emphasize that a lot. Mean, average, they're all completely synonymous. So just like there's an average height in the class, in statistics, we would say the mean height of the class. You get used to it the more and more you hear it, but it might sound weird to your ears already. So when I said around 4 crimes, what I was saying is if we took the average of these data, it's probably going to be right around 4-ish. That's not necessarily completely accurate. We need to compute that ourselves. That was one of the comments we were mentioning with the TID4. We'll compute an average. And that's always something we like to discuss in a quantitative data set. But the mean or average is never the full story. The other important value is not where it clumps up, but how spread out it is. That's really important to us as well. So the other important value we never even mentioned on this is the spread. Let me try to spell this correctly. Computed by the standard deviation. So these are things we're going to think about in these notes in sections 2.2, 2.3. In section 2.4 next week, we'll compute them on these data sets. We'll say, what is the actual average mean value? What is the actual standard deviation, which tells us how spread out all the data is. For the moment, we're just eyeballing stuff, but it's a start. We're seeing where things congregate to get those concepts in line before we compute them exactly. Well, that's the write-up on this one and just the additional comment in green. When we come back on Thursday's class tomorrow, we'll look more into what we mean about different displays of quantitative variables like these histograms, ideas about center and spread. And we're going to eventually go into describing things as being symmetric histograms, skewed symmetric histograms, and those kinds of things. So lots of drawing, all about really dealing with the fundamental graph, the histogram. This is a start. This is just doing the version by hand, and then we'll be looking at it as computer graphics coming up. This is definitely a good stopping point for us. We can't do a problem in 3 minutes, so occasionally we'll end a little bit early. Any last questions at all, folks, before we call it a night? Okay, have a great evening, folks. We'll be back here on example 2 next class. Take care.